Hey there, my name is Mason. I'm the head of engineering at Tulip. I've been in the company for about 8 years and seen it grow from a startup to where it is today. Today I'm going to be talking about moving manufacturing workloads to the cloud and why not all cloud-based solutions are created equally. If the past couple of years have taught us anything, it's that a lot's changing. There's been a huge number of complex and difficult situations thrown at manufacturers over the past 5 or so years, from supply chain issues to labor shortages to COVID to concerns about offshoring. It's a rapidly changing environment, and it's quite difficult to keep up. Thinking forward, adaptability and resiliency are going to be critically important, especially as you think about your technology stack and infrastructure. Being able to design something that can scale to unknown challenges in the future is more important than ever. And over the past 8-10 years that I've been at Tulip, we've seen a lot of manufacturers start to choose the cloud. Back when Tulip started in 2014, there was a real huge desire for on-premise software. And as time goes on, we've seen more and more customers start to push certain workloads to the cloud. Gartner recently did a study on this, and they showed that within the next 4 years, 65% of application workloads will be ready for the cloud, which is pretty, up almost 50% from where we were last year. Now, deploying to the cloud gives an enormous number of benefits in terms of scalability, security, reliability, startup time. We'll talk through all of those throughout this presentation here. To begin with, pushing workloads onto a cloud-based solution gives an enormous scaling and governance benefit. From the purposes and perspective of an individual application, the cloud is almost limitless in resources. It's very trivial to provision another server, add in more different access control based on network requirements, and keep up to date with the latest innovations in server infrastructure and technology in a way that's much more difficult when you maintain your own data center. We've seen cases where customers had trouble upgrading from older versions of, say, like Intel CPUs and things like that really affected their end user performance in a way that would have been pretty seamless if they had been using a cloud. There's also enormous cost savings when switching workloads over to the cloud. Companies like Amazon and Microsoft have massive teams responsible for their infrastructure, literally thousands of people maintaining these data centers, inventing new technologies, scaling, operationalizing them, all of them. And they're doing a really excellent job at that. They're going to have an enormous efficiency of scale here that allows them to provide the same services as you could get in your data center for really a fraction of the cost, not to mention the benefit from being able to suddenly say, I need another 10 servers or something like that. Those same teams are also going to give really reliable and solid security and maintenance. If a server starts having a problem, they'll automatically detect it and work to move you off without you even noticing. Additionally, when you're starting to talk about SaaS companies and their security teams, they have dedicated teams that know their software inside and out and are focused on the security of that specific piece of software. They're going to be able to do that really effectively as they intimately know that surface area. Finally, there's a huge resiliency and adaptability advantage here on the cloud. We've heard from a bunch of manufacturers that when COVID hit and they started having more people work from home, cloud-based solutions were a huge advantage during that transition. Being able to really easily let people access their data from anywhere at any time, usually given a VPN or some other security measure like that, and more dynamically react to the changing environments was a huge competitive edge for them. These days, we walk around with what's really 20 years ago would have been considered a supercomputer in our pockets, and cloud-native solutions allow you to suddenly start using that as a tool in your day-to-day job and not have it siloed inside of a desktop application or something else like that. So let's talk about a couple key keywords here: composable and cloud-native. This is a trend that companies like Gartner have started to identify in the industry as service providers are moving towards distributed, microservice-oriented architectures from a real cloud-native perspective and fundamentals. So originally, when companies started moving their workloads to the cloud, they did so through what's called lift and shift. This meant taking your existing monolithic on-premise application and moving it en masse onto the cloud. Now, this worked initially. It got things off the ground. It provided a really fast avenue towards starting to get something to the cloud. But it was really no different from what IT departments were doing internally of installing an on-premise application on a specific server. The same thing was just happening on a server in the cloud instead. Had some advantages in terms of cost, but didn't actually fundamentally change the principles or architecture of that application. We're now starting to see a new wave of manufacturing software come through that's really and truly cloud native with a distributed microservice architecture. Now, this means that software was purpose-built for the cloud. Its first and primary deployment target was the cloud, and can therefore take advantages of a lot of the economies of scale and different technologies in those clouds in order to enable faster feature development, higher availability, better scale, and things like that. Specifically, this architecture is all about designing different microservices that come together to provide the end solution. So instead of having one service that handles everything for the back end of the software, there might be one microservice that's around users, and one microservice that's around data, and one about applications, and so on and so forth, that then communicate together to form the overall solution. Now, when you design these microservices in a RESTful way, you don't have state in them, it's very easy to start scaling these out horizontally and dynamically adapt to any amount of load on a very granular level. Now, when architecting a system like this, you also end up with built-in extensibility. These services are likely going to talk to each other through a REST API, and that REST API can then become part of the product itself and expose to the end user the same customization points as the company is using internally to develop their software. Now, this means that the API is not an afterthought. It's not bolted on after, it's not half thought out. It is the fundamental core of the thing that is being built and enables an enormous level of extensibility and customization on top of that. This then starts to play into a composable cloud architecture. Instead of having one singular monolithic application with a select series of APIs, you have adaptive, flexible microservice architecture with all of the APIs exposed. This enables other people to build on top and start to create a third-party ecosystem around the platform where you can take those third-party solutions and compose them together into a fully baked solution that covers all of your needs. Now, let's talk about how all of this applies to Tulip specifically and how these fundamental principles have influenced our architecture and development over the past decade. We've always been cloud native. The vast majority of all of our deployments are on the cloud. And we've scaled across the world a number of different data centers to provide better latency for different users around the world. The whole product is microservice architected and multi-cloud and multi-tenant for every single one of those microservices. This is all orchestrated through a tool called Kubernetes that helps scale and automatically adapt our server and infrastructure size to the number of customers that are currently using the product. We're using open source technology like Grafana and Prometheus and Loki in order to monitor and alert on our infrastructure and understand how it's performing in real time as different workloads come onto the platform. We run on both AWS and Azure. We sort of architected the platform to take advantage of the similarities between the two, but not be dependent on any specific proprietary service on either of them in order to allow us to scale better and not be held to any one specific vendor there. This really comes through in how we roll out updates and some of the actual impacts of the product as a result of our architecture. Now, we release on a 2-week cycle. So your sort of standard agile sprint cycle and pretty traditional in a modern software company. So every single 2 weeks, we release a new release that has a whole series of continuous improvements, bug fixes, performance changes, everything like that, and rolls out to our customers over a rolling period of about a week. We then also cut every 6 months a long-term support or LTS release for customers that want to validate and update on a little bit of a slower cadence. Now, this combination allows us to both get really rapid feedback and iteration from our customers and have the governance and lock it down where required. Having said that, even on those LTS customers, 95% of them are still on the latest release because it's been so easy for them to update because of the cloud native underpinnings. Because for us, updating a customer is a minute. We roll it out. It's just like any other update that we do on a bi-weekly cadence. It doesn't matter if it's an LTS or not. Now, we can give them infrastructure and a sandbox and everything like that to let them experiment and test the upgrade before they go. But when they tell us, okay, we're ready, we want you to schedule and update it, 10 p.m. on Friday, it'll be done by 10:02. It's a really seamless, painless process. Now, we've also been able to take advantage of some fundamental cloud architectures, principles, tools that exist in AWS and Azure to better speed our development. One specific example I have here is what's called RPO0, or Recovery Point Objective. Basically, if a system goes down, how much data do you lose? And we lose 0 data. We're able to take advantage of some of the fundamental underpinnings from the hosted databases provided to us from AWS and Azure in order to enable RPO0 for our GXP customers. This was a pretty easy development for us because of the technology we're using and because of the advances in cloud deployments that we're built on top of. It was pretty straightforward for us to get here. For us, this is a sort of a typical reference architecture for a Tulip deployment. And to sort of a closing point here, there are going to be workloads that should remain on-premise. Not everything is meant to go onto the cloud. A safety critical application or a SCADA layer, those make sense on-prem. You need a very, very low latency, very high bandwidth. You want to maintain that LAN connection there for that level of architecture. But when you're starting to get to, say, like an MES or an ERP, something where you might want it to be used on multiple different devices, and it's more of a business capacity than a low-level infrastructure, that makes sense to start thinking about in the cloud and finding ways to link the two, the on-prem system and the cloud system together in order to have that communication. That's where things like Tulip's edge device and connector host come in to mirror the appropriate level of information from the factory floor into the cloud. So with that, that's sort of an end-to-end perspective here on cloud technology, architecture, cloud native, everything like that. It's been a core part of Tulip's architecture since day one, and will continue to be sort of part of how we continue to build the platform going forward.